You've probably had days when everything felt ordinary. You woke up, you looked out the window, you had coffee or tea. You spoke to people, you worked, you thought. You may have stared up at the sky and watched the clouds drift by. The world seemed real because you could feel it. You could touch the table in front of you, hold a glass of water, taste your food, run your fingers over your phone's smooth screen. But tonight, as you lie here waiting for sleep, I want you to hold a question in your mind. Not a frightening question, just one to sit with. What if it's all a simulation? What if the things that feel so solid, so physical, are not quite what they seem? You don't have to believe it. You don't have to worry about it. Just consider it for a moment, the way you might wonder what lies beyond the stars. It's a simple question that has echoed through the centuries in different forms. How do we know what's real? When you were a child, you might have asked someone, "How do I know I'm not dreaming right now?" Some people would say, "Pinch yourself." But even that pain, that sting of your own skin, could be part of the dream. After all, your brain can imagine pain. It can imagine whole worlds when you close your eyes. Think about the last dream you had. Maybe you were flying. Maybe you were walking through a city that felt so real you could read the signs, smell the food, feel the wind on your face. And then you woke up, and it was gone. The city dissolved, the food vanished. Only you remained, lying in bed, a little confused by how real it all felt. Now think about how strange it is that your mind can make a world that feels real, yet it's only neurons firing in your brain. You could be standing in an empty field. You could be on the other side of the world. It's just you and your brain's stories. The idea that life itself might be a kind of dream is not new. Ancient philosophers, monks, and mystics have wondered the same thing. Long before computers, people were asking if reality might be an illusion, a shadow, a reflection on the wall of a cave. But something changed when humans began to build machines that could think, or at least process information like a mind. In the last few decades, computers have become so powerful that they can create entire worlds out of code. A game you play on your phone has landscapes, cities, people. It follows rules. It has gravity, light, weather. It tricks your brain just enough to make you feel you're somewhere else for a little while. Of course, you know you're looking at a screen. But what if the screen were so good you couldn't tell? What if it surrounded you completely, responding to every move, every word, every tiny thought? Would you know you were in a simulation? Consider this. The simplest computer simulations started with a handful of shapes, just dots on a screen. Then came more detail, pixels forming pictures, animations moving smoothly, sounds matching every motion. Today, we have virtual reality headsets that can fool your eyes, your ears, and even your sense of balance. Some scientists and philosophers wonder if this is a clue. If we can build small, imperfect simulations now, what could someone build in 1,000 years? Or 10,000? Maybe an advanced civilization, or even humans in the distant future, could make a simulation so perfect that the people inside it would never know. If you've ever watched a science fiction movie, you've probably seen this idea before. A hero wakes up and discovers the world they thought was real is only a computer program. The story feels far-fetched, but the question behind it is serious enough that some of the world's leading thinkers have spent years discussing it. A philosopher named Nick Bostrom famously argued that if it's possible to simulate conscious beings, then there's a good chance that we are those beings. Why? Because if an advanced civilization can run one simulation, they can run thousands, maybe millions. That means the odds of us being in the base reality, the real, original world, could be tiny compared to the odds of us being in a simulation. It sounds dramatic, but it's really just math. If there are more simulated people than real ones, chances are you're one of the simulated ones. Now, before that makes you feel strange, think about this. Does it matter? If everything you feel still feels real, if you still have memories, if you can still love, dream, and laugh, then the simulation is your reality. For all practical purposes, it's real to you. The question remains, though, could there be clues? Is there any sign that we're in something artificial? Some physicists point to the strange behavior of particles at the smallest scales. Quantum mechanics is so weird, it almost looks like a computer refreshing its pixels when you look closely enough. But so far, there is no proof, only ideas. When you look up at the night sky, when you see stars, distant planets, the faint glow of a galaxy, you might wonder if those lights are like the painted ceiling of a dome, or if they stretch out forever. You might wonder if the rules you believe are constant, gravity, light, time, are really written in stone, or just lines of code in a vast cosmic program. None of us can say for sure, and maybe that's part of the point. Maybe wondering is the whole idea. To be conscious is to ask questions, to notice the world, to poke at the edges of what you believe to be true. So as you lie here tonight, your eyes growing heavier, your mind drifting between the feeling of your bed and the thought of something bigger, remember that it's just a question. You don't have to find an answer. You don't have to solve it. Sometimes the questions themselves are enough. Sometimes they are what make life interesting, even if life is a simulation. So take a deep breath, feel the pillow under your head, listen to the world around you. You are here, right now. Maybe you're lines of code, maybe you're flesh and bone, maybe you're both, in a way no one fully understands. Either way, you can close your eyes knowing that the world will still be here when you wake up, or at least the world you know. And tonight, that's real enough. Long before anyone imagined computers or video games, people wondered if what they saw around them was the whole story. Thousands of years ago, without electricity or screens, thinkers sat under the open sky and asked, "What is this place? How do I know it's real? Could I be wrong about everything I see and feel?" One of the oldest stories about questioning reality comes from ancient Greece. The philosopher Plato, living around 2,400 years ago, gave us an image that people still talk about today: the allegory of the cave. In this thought experiment, Plato asks you to picture people who have spent their entire lives chained inside a dark cave. They can't turn their heads. All they can see is the wall in front of them. Behind them, there's a fire. Between the fire and the prisoners, other people walk by, carrying objects, statues, plants, animals, that cast shadows on the wall. The prisoners see only these shadows. To them, the shadows are reality. They don't know about the fire behind them. They don't know there are people moving around freely. The shadows are all they have ever known. Now imagine that one prisoner breaks free. He turns around. The fire blinds him at first, but he realizes that what he thought was real, the shapes on the wall, were just shadows. He's curious. He leaves the cave and steps out into the sunlight. Outside, he sees the real world for the first time. Trees, rivers, mountains, the sun itself. He realizes how deep his ignorance was. Plato's point was that we too might be prisoners, mistaking shadows for reality. Maybe what we see and feel is only a limited version of something bigger and truer. He didn't use the word simulation, of course. There were no computers to compare it to, but the idea is the same. What you see might not be the truth. Centuries after Plato, the same question returned in different forms. In ancient China, a philosopher named Zhuangzhou told a simple but haunting story. He once dreamed he was a butterfly, floating freely on the breeze. When he woke up, he wondered, am I Zhuangzhou who dreamed he was a butterfly? Or am I a butterfly now dreaming he is Zhuangzhou? The line between dream and reality was blurred. The dream felt real when he was inside it. The waking world felt real when he opened his eyes. How could he be sure which was which? These ancient doubts spread across cultures. In India, Hindu and Buddhist thinkers spoke about the world as Maya, meaning illusion or magic. According to some traditions, the world as we see it is a kind of veil that hides the true nature of existence. The things you touch and see are not the ultimate reality. They're just a passing appearance. In medieval Europe, the philosopher René Descartes, living in the 1600s, asked himself how he could be sure of anything. How could he trust his senses? What if every sight, every sound, every taste was a deception? He imagined a powerful demon, clever and malicious, who could fool him completely, creating the illusion of a world that doesn't really exist. Descartes struggled with this problem for years. In the end, he settled on one thing he believed he couldn't doubt: the fact that he was thinking. I think, therefore I am. Even if he was deceived about everything else, the very act of doubting proved that he existed in some form. These ideas might sound abstract, but they pop up in ordinary life all the time. Have you ever woken from a vivid dream and felt disoriented? For a few seconds, you wonder where you are. Which part was the dream, and which is real? Your mind accepts both, depending on where you are. Or think of illusions, simple tricks that fool your eyes. A stick dipped into water looks bent. A mirage on a hot road makes you think you see water that isn't there. A magician can make a coin disappear right in front of you. Your senses can be tricked, even when you know how the trick works. Even our memories, which feel like solid proof of our lives, can be fragile and misleading. Two people can see the same event, but remember it in completely different ways. Details shift, moments blur, new information slips in without us noticing. The brain is powerful, but it's not perfect. It fills in gaps, smooths out contradictions, makes guesses. We trust it because we must, but deep down, we know it can lie to us. When you lie in bed, thinking about these ancient questions, it can be unsettling, but it can also be comforting. If people thousands of years ago wondered the same things, it means you're not alone. Doubt is part of being human. The need to test reality, to peek behind the curtain, to ask, what if, That's something we all share. And the more you think about how these old ideas connect to our world today, the more fascinating it becomes. In the time of Plato, the biggest mystery was the difference between shadows and sunlight. Now we have computers that can generate moving images more complex than any shadow on a cave wall. We have virtual reality headsets that can convince your eyes you're standing on a mountaintop when you're really in your living room. The shadows have grown more sophisticated, yet the core question remains the same. How do you know what's real? Is there a fire behind you, casting illusions you can't see? Is there a wider world you haven't yet turned your head to glimpse? Some people spend their whole lives chasing that truth. Mystics meditate for years, trying to see through the veil. Scientists build experiments to test reality's smallest pieces, searching for signs that the universe might not be as solid as it seems. Philosophers keep writing books, each generation adding a new layer to an ancient question. As you lie here tonight, you don't need to find an answer. There may never be one. But you can drift to sleep knowing that your doubts connect you to centuries of thinkers, dreamers, and wanderers. You can close your eyes knowing that reality is richer than it appears, and that even if you never see what's behind the wall, it's worth wondering what might be there. The shadows flicker on the cave wall. The butterfly flutters through the dream. The demon whispers doubts that make you ask, "How do I know?" And you, warm in your bed, simply listen to the question echo quietly in your mind, a gentle reminder that sometimes the search is enough. You are here, and you are thinking, and for now, that's real enough. Imagine for a moment that your mind, everything you think you are, is not inside the world you see, but instead floating in a jar connected to a machine that feeds you every sight, sound, and touch you believe is real. This is the classic idea known as the brain in a vat. It's not meant to frighten you, but to stretch the question of what you can truly trust. The thought experiment is simple. Picture a single human brain kept alive in a clear glass vat filled with the right nutrients. Wires run from this brain to a supercomputer. The computer sends electrical signals to the brain, imitating everything you'd expect to feel if you had a body. When the computer says, "You are sitting in a chair," the brain feels the pressure on its back, the weight under its legs. When the computer sends the signal for, "You are eating a strawberry," the brain tastes sweetness, feels the texture, and believes it's chewing. From the brain's perspective, it's all happening, even though there's no real chair, no real strawberry, and no real world outside the vat. This idea took shape as philosophers like Hilary Putnam in the 20th century revisited the old question, how do you know what you know? A brain in a vat would have no way to tell the difference. Its entire reality would come from a machine feeding it signals. To the brain, the simulation would feel as real as life does to you now. You might wonder, is this possible? In theory, the basic idea makes sense. Our brains already depend on electrical signals. Light bounces off objects, hits your eyes, and is translated into signals your brain interprets as images. Vibrations in the air become sounds when your ears catch them and your brain decodes them. A soft blanket feels soft because nerves in your skin send signals that the brain turns into the feeling of warmth and comfort. The brain itself never sees or hears or touches anything directly. It relies on signals. So, If a machine could perfectly imitate those signals, it could trick the brain. Right now, our technology is nowhere near that level of precision. But even if it never happens, the thought experiment itself reveals something important about how fragile our sense of reality can be. Science fiction has borrowed this idea many times. In movies and books, characters wake up to discover their entire lives were virtual, their bodies floating in tanks, while machines fed their minds a world that felt genuine. The concept fascinates people because it feels close to something we already experience: dreams. In a dream, your brain creates an entire world that feels real enough to believe while you're in it. You run, you talk, you taste, you feel fear or joy. Then you wake up and realize none of it happened. If a short dream can do that, what could a powerful computer do? Neuroscientists study how the brain builds its model of the world. Even without fancy machines, your mind can make you see or feel things that aren't really there. Optical illusions show us how easily sight can be fooled. Hallucinations can appear without any real trigger. Under certain conditions, like lack of sleep, extreme stress, or the influence of certain chemicals, people sometimes see things that feel as real as any physical object. In experiments, researchers have even shown how the brain can be tricked into thinking your body is somewhere it isn't. One famous example is the rubber hand illusion. A participant places one hand on a table hidden from view by a barrier. In front of them is a realistic rubber hand. The researcher strokes the hidden real hand and the fake rubber hand at the same time in the same way. After a while, the participant feels like the rubber hand is part of their body. Their brain combines what it sees with what it feels, creating a false sense of ownership. The real hand can be poked, and the person reacts as if the rubber hand is in pain. It's a simple trick, but it shows how quickly your brain stitches together reality from what it's given. If it does that with a fake hand, what about an entire world? In some ways, you are already living in a version of a simulation, not because you're hooked up to a computer, but because your brain builds its understanding of the world second by second, based on imperfect information. You never see reality directly. You see a version of it, filtered through your eyes, ears, skin, and memory. Think about how the brain edits what you notice. You don't feel your clothes touching your skin every moment of the day because your brain decides it's not worth your attention. You don't hear every hum of electricity in the walls or feel every shift of the air. Your brain filters these details out so you can focus on what it thinks matters. But all those signals still exist. They're just set aside, like background code. This raises another question. If your brain filters and edits your experience, how much of your reality is missing? And if something, or someone, wanted to change what you see and feel, would you know? This is where the brain in a vat comes back again. If you were only a brain, if every sense could be perfectly faked, your entire existence would be shaped by the inputs you're given. The people you meet, the memories you hold, the places you think you've been. All of it could be crafted by the machine. From your perspective, it would be indistinguishable from a real life. Of course, there's no evidence that you are actually a brain in a vat. Scientists have never found a clue that we're wired up to some cosmic computer. But the point of the idea isn't to prove you are. It's to show you how your mind works and how delicate your trust in your senses really is. Some people find this unsettling, others find it freeing. If you know your reality depends on your brain's signals, you can appreciate how powerful your mind really is. It's not just a passive receiver, it's an active creator. It builds your world moment by moment, making sense of countless signals so you can go about your day. Lying in bed, you can feel the mattress under your back, the air moving in and out of your lungs, the quiet or not so quiet sounds around you. All of it is part of your brain's careful assembly. Whether you're a brain in a skull or a brain in a vat, your experience is still your own. It's the only version of reality you have. So the next time you close your eyes, you might think about how dreams and wakefulness blur together. You might remember that your brain is always painting the world for you, whether it's real, virtual, or something in between. That doesn't make life meaningless. It just makes it more interesting to wonder about. And tonight, you can let that question sit gently in the back of your mind. If I were just a brain in a vat, would I ever know? Maybe not. But the warmth of your bed, the rhythm of your breath, the quiet thoughts drifting through your head, they feel real enough. For now, that's all they need to be. Think back just a little more than 100 years ago. In the early 1900s, there were no personal computers, no smartphones, no glowing screens in pockets and bedrooms. People wrote letters by hand. They read newspapers for news, and calculations, whether for taxes or rocket parts, were done by people, sometimes called computers themselves, because their job was to compute. The idea that a machine could think like a human brain seemed impossible then. Machines were for factories, metal arms and conveyor belts that stamped out car parts or canned food. But the seeds of what would become our modern computers were already there, hidden in small inventions and abstract ideas. One early sign came in the 1830s, when a man named Charles Babbage designed what he called the analytical engine. It was never fully built in his lifetime, but on paper, it was a mechanical machine that could follow a sequence of instructions, an early version of a programmable computer. Babbage's friend Ada Lovelace, who studied his work, is often called the world's first computer programmer. She imagined that one day, machines like this could manipulate not just numbers, but ideas, even music or art, if those things could be translated into symbols and rules. Decades passed. In the 1930s and 40s, new breakthroughs came from people like Alan Turing. Turing proposed the idea of a universal machine, a single device that could carry out any calculation, given the right instructions. His idea is still at the heart of every computer today. Turing machines were theoretical, but World War II pushed these theories into reality. Early computers like the British bomb and the American ENIAC were massive, rooms filled with whirring vacuum tubes and wires. They broke codes, plotted artillery trajectories, and took days to do calculations your phone now does in less than a second. As you lie in bed, think about how short a time ago that was, a blink in human history. In just a few decades, machines went from clunky metal calculators to powerful tools that could store and process more data than entire generations of people could gather by hand. By the 1970s, computers began shrinking from giant mainframes to something that could fit on a desk. In California, engineers tinkered in garages, building circuit boards and keyboards. Companies like Apple and Microsoft grew out of that culture. Young people imagining that everyone might one day have a computer at home. It seemed like a fantasy at first. Why would an ordinary family need a computer? The answer turned out to be simple: information. Computers could store recipes, help balance budgets, play games, and later connect people to the early internet. And with each new generation of machines, they got faster, smaller, and more deeply woven into daily life. By the 1990s and early 2000s, the internet linked millions of computers together. Suddenly, you could sit in your bedroom and send a message to someone on the other side of the world. You could read about any topic at any hour. Ideas that would once take months to share by letter could appear on a screen instantly. The line between real life and the digital world began to blur. It didn't stop there. Developers and engineers built virtual worlds inside these machines. Simple games at first, blocks and pixels, then complex environments with cities, landscapes, and characters who talk and move. Video games became more than toys. They became experiences, places people could visit and spend hours in. People began to ask questions. If a game can be so convincing that you forget where you are for a while, what happens when it becomes more lifelike? Virtual reality headsets put screens inches from your eyes, tricking your brain into believing you're inside a new place. Sensors track your head, your hands, your eyes, feeding new information back to the computer. The illusion grows stronger. Even without special headsets, millions of people live part of their lives online every day. You might wake up, scroll through news, watch videos, message friends, all inside a digital world. If you play an online game, you might have memories from it as vivid as any afternoon in a park. The conversations, the moments of surprise or triumph, the communities you join. They exist only as lines of code, but they feel real. Some scientists, futurists, and philosophers look at this and ask, if we can build these small, imperfect simulations now, where does it lead? What happens when computers grow even more powerful? What happens when artificial intelligence learns not just to follow instructions, but to adapt, predict, and mimic human thought? Today's most advanced computers can already beat chess masters and Go champions. They can generate human-like writing, translate languages, and learn patterns from oceans of data. Machines that once filled entire buildings now fit in your pocket. They answer your questions, guide your car, recommend your next movie. In some fields, computers help doctors find diseases earlier than ever. In others, they help scientists test theories too complex to solve by hand. The question some thinkers pose is simple. If this is what we can do now, what might a civilization thousands or millions of years ahead of us be able to do? If we assume technological progress continues, wouldn't it be possible to build a simulation so perfect that the people inside it wouldn't know they were simulated? This idea connects back to the simulation hypothesis. The philosopher Nick Bostrom famously argued that future civilizations might run simulations of their ancestors, digital worlds so realistic that the people inside would believe they were real. If even a small fraction of advanced civilizations ran many such simulations, then statistically, most beings like us would be inside one. The rise of computers made that question more than just science fiction. It turned it into a problem people debate seriously. As you lie here, think about your phone, your laptop, your TV screen. Each one is a window into another world. And behind each screen is a stack of code, algorithms, data, instructions telling light and sound what to do. The more powerful our computers get, the deeper those worlds can become. Maybe one day, a person will wake up inside a world so detailed that every grain of sand, every leaf on a tree, every heartbeat will follow rules written by someone or something else. Maybe they'll live an entire life, never suspecting their lines of code running in a machine. And maybe, just maybe, we're already there. It's not about fear. It's about curiosity. The same curiosity that drove Babbage, Lovelace, Turing, and the garage tinkerers who imagined you might have a tiny thinking machine on your desk. Each step brought us closer to creating worlds within worlds, questions within questions. Tonight, you don't need to solve the puzzle. You just need to remember how fast it all happened. From gears and levers to supercomputers and virtual realities, the story of how computers rose is really the story of how we learned to mimic the mind, and maybe someday mimic an entire universe. So as you settle deeper under your blanket, let your own mind drift through that quiet hum of circuits and screens. Somewhere, machines run millions of calculations every second, powering your shows, your messages, your games. They whisper that bigger questions may lie ahead. Look around your room for a moment. That's enough to think about. Or picture it in your mind. The walls, the ceiling, the furniture, the tiny details like the weave of your blanket or the texture of the floor. If you went outside and looked up, you'd see the sky, the sun or stars, maybe the glow of the moon. All of it feels solid. It feels continuous, like reality is one smooth, unbroken thing. But what if it's not? What if, deep down, the universe is made not of continuous stuff, but of tiny units of information, a kind of cosmic code? It's an idea that comes up in physics, computer science, and philosophy. The possibility that reality behaves more like digital data than like a continuous movie reel. Think of how a picture on your phone works. What looks like a smooth photo is really made of pixels, tiny squares of color so small your eyes blend them together. Each pixel's color is defined by numbers, red, green, blue values stored in the device's memory. The photo isn't an unbroken image. It's data, arranged to fool your eyes. Scientists wonder, could space itself be like that? Not made of smooth matter, but tiny units, bits like digital pixels that build up everything you see. At the smallest scales, reality already behaves in ways that seem quantized. The word comes from quantum mechanics, the branch of physics that studies particles smaller than atoms, electrons, quarks, and so on. In this realm, energy, matter, and even light aren't perfectly smooth. They come in discrete amounts. An electron can't have just any amount of energy. It can only jump between allowed levels. It's like walking up a staircase instead of sliding up a ramp. You can stand on each step, but not in between. This chunkiness made some physicists wonder if the universe could be like a computer simulation running on code. In a computer, the smallest unit is a bit, a 1 or a 0. Combine billions of these bits in the right way, and you can create an entire world inside a screen. If the universe is digital, maybe the smallest units of space and time are like those bits. In the 1940s, physicist John Archibald Wheeler suggested something called it from bit. He believed that, at its deepest level, everything physical, matter, energy, space, and time, comes from bits of information. It, the thing you touch and see, comes from bit, the binary yes or no decision. It sounds strange, but think about how much of your life already depends on information. Your phone, your computer, your bank account, your photos, your messages, they're all just streams of data. Information moves from place to place, changes shape, but remains the same at its core. If our technology runs on bits, why couldn't nature? To test this idea, some researchers look for clues in the cosmic background, the faint glow left over from the Big Bang. If the universe has a built-in grid, like pixels, there might be tiny distortions or limits to how precisely we can see distant stars. So far, no one has found clear evidence, but the search continues. Another place this idea shows up is in the holographic principle. This theory says that the three-dimensional world you see might be like a hologram, an image that appears 3D but is actually encoded on a flat surface. In the 1990s, physicists studying black holes realized that all the information about what falls into a black hole could be described not by its volume, but by its surface area. It's like all the stuff inside could be written on its boundary. Extend that to the universe. Some scientists think the information that makes up your reality might be stored on a cosmic boundary you can't see. What you think of as depth, space, and time could emerge from this encoded data. Of course, it's not proven. The math works for certain conditions, but no one has measured the boundary directly. Still, the idea fascinates people because it suggests that the deepest structure of reality might be something like a code, an instruction set that tells the universe how to behave. If you've ever looked at a video game up close, you know that a tree in a game isn't really a tree. It's a set of rules, a texture for the bark, a shape for the trunk, some physics for how branches sway in the wind. The computer doesn't need to store every leaf. It generates what you see when you look at it, saving memory, making the game run smoothly. Some physicists wonder if the universe does something similar. At the quantum level, particles exist in a fuzzy state until you measure them. It's as if reality only renders what you look at. This doesn't mean the world disappears when you close your eyes, but it does mean that measurement seems to pull possibilities into one outcome. That idea feels suspiciously like how a computer saves processing power, only display what the player needs. Another clue comes from mathematical rules. Everything in physics seems to follow strict patterns, equations that predict how things should move, interact, and change. Some scientists think this precision could be a sign of an underlying code. Others say it's just how the universe works. Math happens to describe it well because we made math to match what we observe. Either way, it raises a question. If there is code, who or what wrote it? Maybe no one. Maybe code is just a metaphor for natural laws. Or maybe it's something deeper, a structure that acts like software for the universe. You don't need to decide tonight whether you believe the universe is coded like a computer game. Just think about how strange it is that the smallest building blocks of reality are so different from the everyday things you see and touch. At your scale, a rock feels solid and heavy. At the atomic scale, it's mostly empty space. At the quantum scale, it's a cloud of probabilities, waiting to be pinned down. And yet, all this uncertainty makes your world possible. The electrons in your body obey these quantum rules, creating the chemistry that lets you breathe, think, and dream. If reality is a code, you're part of it. Your thoughts, memories, and imagination all depend on these tiny pieces of information. Some people find that unsettling. Others see it as a reminder that even the simplest things, a stone, a raindrop, a whisper in the dark, might hold more secrets than we can ever see. The universe could be written in a language we're only beginning to decode. As you lie in bed, take a moment to feel how much is happening at once. Billions of particles bounce inside your body every second, following rules they can't break. Light travels for billions of years to reach your eyes when you look at the stars. All of it might be part of a pattern, an elegant system that runs like software on a machine so vast we can barely imagine it. Tomorrow you'll wake up and go about your day, touching the same walls, the same floor, the same familiar things. They'll feel solid, and they are. But somewhere beneath that surface, there might be something even more interesting. A universe of code, humming quietly, building reality bit by bit. And for now, that idea is enough to keep you company as you drift off. Think about the screen you're probably using right now. A phone, a tablet, a computer. When you look at an image, it seems smooth and continuous. But you know that if you zoom in far enough, it breaks down into tiny squares, pixels. Each pixel holds color and brightness information. Millions of these tiny squares combine to create what you see: pictures, videos, words. Without pixels, there would be no clear image. This idea that something smooth is really made of tiny units has given scientists a new way to think about the universe itself. What if reality, like your screen, is not perfectly smooth, but pixelated at the smallest scales? It starts with a basic fact. In our everyday world, space feels continuous. You can walk across a room, move your hand in the air, and there are no gaps. But when physicists study nature's smallest building blocks, the realm of quantum mechanics, they find signs that reality may not be infinitely divisible. One clue comes from the Planck length. This is a number physicists use to describe the smallest meaningful unit of distance, about 1.6 times 10 to the minus 35 meters. It's so tiny that it's impossible to see directly, even with our best instruments. But it represents a point where our current understanding of physics breaks down. Below this scale, space and time might not make sense the way they do at larger sizes. Think of the Planck length like the pixel size of the universe. Just as you can't have half of a pixel on your screen, maybe you can't have half a Planck length in reality. Below that point, the idea of distance might lose its meaning entirely. This pixel theory is connected to another idea in physics called loop quantum gravity. This theory tries to combine quantum mechanics and general relativity, two pillars of modern physics that don't always fit together neatly. Loop quantum gravity suggests that space itself might be made of tiny loops woven together, forming a kind of network. In this view, space is not a smooth fabric, but a lattice. You can picture it like a three-dimensional mesh that holds the shape of the universe. The loops are unimaginably small, but they give structure to everything: the air you breathe, the light that passes through your window, the stars you see in the sky. If space is pixelated, time might be too. The Planck time, about 5.4 times 10 to the minus 44 seconds, is thought to be the smallest meaningful unit of time. Below that, the concept of before and after may not apply in the way we understand it. It's strange to imagine that reality could be like a stop-motion film, tiny frames flickering by so quickly that you can't see the breaks. To us, it feels continuous, but deep down, there could be gaps between each frame. This idea doesn't just come from theoretical physics. Some scientists have looked for ways to test whether space is pixelated. One approach is to study light from distant objects, like quasars, bright, ancient sources of energy billions of light years away. If space were pixelated, you might expect to see subtle distortions in the light, tiny blurriness where you'd expect a sharp line. So far, no clear evidence has been found, but experiments continue. Another clue comes from computer simulations themselves. In a game, the world you see is built from pixels or polygons. When you look at a wall or a tree, your device only shows you what it needs to display. The parts you can't see don't need to be rendered. This saves memory and processing power. Some physicists wonder if the universe works similarly. Quantum mechanics shows that particles don't have definite properties until they're measured. For example, an electron doesn't have a fixed position until you look for it. Before that, it exists as a cloud of probabilities. It's as if the universe renders only the parts you interact with, like a computer game only showing you what's on screen. This doesn't mean that reality is fake or that we're living in a cheap game. It's more of a question. Why does the universe behave in a way that resembles how computers manage information? Is this a hint that the universe is itself a kind of information system? Or is it just a useful way to describe natural processes? Thinking of reality as pixelated also raises deeper questions about limits. In the digital world, higher resolution means more pixels and clearer images. But higher resolution needs more storage and more processing power. Could the universe have a limit to how much information it can store? This idea connects to the holographic principle, the theory that all the information inside a region of space can be described by its surface area, not its volume. It's like saying that what happens inside your room could be fully described by the data stored on its walls. If true, this would mean that there's a maximum amount of information you can pack into any space. In a sense, it's like saying there's a maximum pixel count for reality. Of course, none of this means we have final answers. It's hard to test ideas at such tiny scales. Our instruments can't reach the Planck length or Planck time. We can only look for indirect signs, slight patterns in cosmic radiation, small irregularities in gravitational waves, or tiny shifts in particle behavior. As you lie here, think about how strange it is that these questions come from looking closely at everyday things. A simple photo on your phone reminds us that big, clear images come from tiny pieces working together. The closer you zoom, the more you see the building blocks. The universe might be the same, its vastness hiding a tiny structure we can barely imagine. Every breath you take, every sound you hear, every thought in your mind happens within this pixelated framework, if that's really what it is. It doesn't change how you feel the softness of your blanket or the steady beat of your heart, but it adds another layer to the story, the possibility that reality is not a smooth, endless fabric, but a pattern of tiny units stitched together like a cosmic quilt. When you look up at the stars, You see points of light that traveled billions of years to reach you. Those photons, tiny packets of energy, move through space one step at a time, crossing the tiny loops or pixels that might form the scaffolding of the cosmos. They don't know they're following rules. They just move, carrying information from one place to another. So tonight, as you drift off, remember that what seems continuous might not be. Underneath the smooth images is a deeper pattern, a hidden grid, a silent structure, a universe that might be pixelated at its core. And whether we ever see those pixels directly or not, the idea reminds us that reality can hold surprises far smaller and far stranger than our eyes can see. Every now and then, you might experience something that doesn't quite fit. You set your keys down in one place and later find them somewhere else you swear you never put them. You look at the clock and see the same repeating numbers again and again. 11:11, 2:22. You walk into a room and feel like you've already been there before, though you know you haven't. These moments are small and easy to shrug off. You might call them coincidences or just a lapse in memory. But some people see them as something more, possible glitches in the reality we think we understand. The idea of a glitch in the Matrix comes from a famous scene in the 1999 movie The Matrix. In the film, the main character, Neo, sees a black cat walk by a doorway twice in exactly the same way. It's a moment of déjà vu, that eerie sense that you're repeating something you've already lived. In the story, the glitch means the computer simulation that makes up Neo's reality has changed something, and the déjà vu is a clue that the world isn't what it appears to be. Of course, that's fiction, but the idea has stuck around because it gives people a way to describe those little moments that feel off, moments when you wonder if the program behind your life just stuttered for a second. One of the most common glitches people talk about is déjà vu. It's a French term meaning already seen. Nearly 2/3 of people report having this feeling at least once in their lives. You walk into a new place, a cafe you've never visited, and for a few seconds, you're convinced you've been there before. The furniture, the smell, the voices, all of it feels strangely familiar. Then the feeling fades, and you're left puzzled by how real it seemed. Scientists have studied déjà vu for years, looking for a clear explanation. One theory is that it's caused by a brief hiccup in the brain's memory system, a moment when new information gets mistakenly flagged as a memory. Another theory suggests that your brain sometimes processes information out of sync. You see something, and your brain stores the memory at the same time it processes it as a new experience, making you feel like it happened twice. There's also the idea that déjà vu might be related to the brain's pattern matching. Humans are wired to look for patterns. It's how we make sense of the world. When something feels familiar, it could be that your brain has found a pattern similar to something you once saw or did, even if you don't consciously remember it. But glitches aren't just about déjà vu. Some people describe time slips, moments when they feel like they jump forward or backward in time for a split second. Others talk about the Mandela effect, a name given to the phenomenon where large groups of people remember something one way, only to find out it never happened that way. The name comes from the South African leader Nelson Mandela. Some people remember seeing news reports that Mandela died in prison in the 1980s. But in reality, he was released and went on to become president of South Africa before passing away in 2013. This isn't just a single person's false memory, it's shared by thousands who insist they recall it clearly. Other examples include people swearing that the children's book series was called The Berenstain Bears, when the actual name is The Berenstain Bears, or remembering a famous line from a movie one way, like Darth Vader saying, "Luke, I am your father," when the real line is, "No, I am your father." These little inconsistencies make people wonder, is it bad memory, or could they be glimpses into alternate versions of reality? Scientists and psychologists say that these so-called glitches are just quirks of the human brain. Our memories are not like video recordings. They're more like reconstructions, pieces put together each time we remember something. Details get changed or dropped. If enough people share a mistake, it starts to feel real, like a collective memory of something that never happened. But the simulation idea gives people a different way to think about it. If reality were like a computer program, then small errors could happen, just like bugs in any software. Maybe a line of code misfires, or some bit of data gets written twice. A déjà vu could be a tiny loop in the program. A memory that never really happened might be leftover code from another version of the simulation. No one has ever found real evidence that these everyday oddities prove we live in a simulation. But they do highlight something important. Our minds can't always be trusted to record and replay the world perfectly. Your brain is powerful, but it's not flawless. Think about the times you've lost track of how you got somewhere. You drive a familiar route and suddenly realize you don't remember the last few miles. Your mind goes on autopilot, filling in the blanks. Or you have a conversation and later disagree with someone about what was actually said. These moments feel ordinary because they happen all the time, but they remind us how easily the brain edits our experience. If our perception can glitch, it's not hard to imagine why people might wonder if the world itself can glitch too. There are even places in physics where the math hints at bugs in the system. Quantum mechanics shows that particles can behave unpredictably, jumping from one state to another with no clear cause. Entangled particles can affect each other instantly, no matter how far apart they are. It's as if information moves faster than light, something that shouldn't happen under the rules of classical physics. Some physicists think this quantum weirdness could be another sign that reality is more like a coded system than a smooth, continuous world. Other researchers look at cosmic rays, high-energy particles that travel across the universe. Some theories suggest that if space were like a grid or pixelated structure, we might see patterns or alignments that don't quite make sense. Tiny, unexplained variations could hint at an underlying code, or they could just be random noise. No one knows for sure. So far, the universe works well enough that we don't see obvious, repeatable glitches. The laws of physics hold together. The stars don't suddenly blink out. You don't wake up to find gravity turned off. But the little moments, the misplaced keys, the repeating numbers, the feeling of, "I've done this before," are reminders that what we experience is filtered through a mind that sometimes misfires. Whether they're truly glitches in a simulation or just quirks of biology, they open the door to wondering, what if? As you lie here tonight, you don't need to solve the mystery. The universe runs as it always has, patterns and rules carrying on whether you notice them or not. But next time something small feels out of place, you might pause for a second and remember this idea. that even the smallest glitch, real or imagined, invites you to look closer at the world and at the mind that tries to make sense of it. And sometimes, that gentle curiosity is enough to keep you company as you drift off. If the idea that the universe might be a simulation makes you wonder how it could work, the next question is who or what would be behind it. After all, every computer program has a programmer. Every simulation has a system that runs it. So if reality is some giant code, then who's sitting at the keyboard? One possibility often discussed by scientists and philosophers is that an advanced civilization could run it, perhaps far more advanced than we are today. Think about how far humans have come in just a few generations. Less than 2 centuries ago, we were sending messages by telegraph and lighting lamps with whale oil. Today, we can build realistic virtual worlds on devices small enough to fit in your pocket. This pace of progress suggests that if intelligent life survives long enough, its technology could reach a point where creating realistic simulations of entire worlds, maybe even entire universes, is possible. The philosopher Nick Bostrom famously described this in his simulation argument. He suggested that a civilization with enough computing power might run ancestor simulations, recreating what life was like for their distant past. It could be for research, entertainment, or curiosity. If that's true, there could be countless simulated worlds. A single advanced civilization might run millions or billions of simulations. If so, there could be more simulated beings than real ones, making it statistically likely that you're one of them. Why would anyone bother to do this? One reason might be scientific. Imagine you're a scientist in the far future. You want to know what the world was like before your time, to test theories about how people behaved, how societies rose and fell, or why certain events unfolded the way they did. Running a simulation would let you watch history happen over and over again, changing variables to see different outcomes. Another possibility is curiosity. Humans already do this on a small scale. Historians use computer models to study ancient trade routes or population movements. Economists simulate markets. Climate scientists build models of Earth's future, adjusting factors to see what might happen. These are just the early versions of what a civilization with far greater resources might do. Then there's entertainment. If you've ever played a video game with characters who respond to your actions, you've seen a small version of a simulated world. In the future, simulations could be far more detailed, with digital people so realistic that they feel truly alive, to you and to themselves. It might sound unsettling, but it's not that strange when you think about what people already do. Every day, people write stories, make movies, design games, and create virtual characters. The idea that someone would build a detailed simulation just because they can doesn't seem so far-fetched once you see how often humans do it already. Another idea is that the simulation isn't run by a civilization at all, but by an artificial intelligence, a supercomputer that operates on its own. Maybe it was built by a species that's now gone or has moved on to other things. The AI would keep the simulation running, managing the data, correcting small errors, and making adjustments as needed. In this scenario, there might not be anyone watching you or pulling strings. The simulation would just continue because that's what it was designed to do, to run endlessly, maintaining the illusion of reality for its inhabitants. Some people go further and ask whether the programmer could be something we'd think of as divine, an idea that overlaps with older spiritual beliefs. Long before computers existed, humans wondered if life was created and maintained by a higher being. Today's simulation idea is not exactly the same, but it echoes the question: if our world is controlled or created, what does that make its creator? Some argue that the concept of a simulation blends science and philosophy in a new way. It suggests that the universe might have an underlying order, like code written by someone or something. It raises questions about free will, too. If someone is running the simulation, are they just watching, or do they intervene? In everyday life, most people don't feel like they're being manipulated by hidden programmers. You make choices. You feel your thoughts are your own. But if the simulation idea were true, could it be that some parts of life are pre-written? Or would the programmers give you freedom to act and see what happens? In science fiction, you see this question play out in stories where characters discover they're inside a simulation. Sometimes they rebel, trying to break free or find the ones responsible. Other times, they accept it, because in the end, their thoughts and feelings still matter to them, even if they're coded. One thing that makes this question so interesting is that we have no proof either way. There's no evidence that a programmer is out there, changing the weather to test how we react or tweaking someone's luck just for fun. But it's a reminder that if a simulation is advanced enough, the inhabitants wouldn't be able to see its edges. They'd be inside the system, following its rules. Sometimes people point to the rules themselves, the laws of physics, as a sign that there could be a programmer. The universe runs on patterns and equations that never seem to break. Gravity always works. Light always moves at the same speed. It's as if there's a set of instructions holding everything together. Could that be the code someone wrote? Or is it just the way nature works, with no hidden hand guiding it? No one can say for certain. The simulation idea also opens up questions about our own future. If humans become advanced enough, would we run our own simulations? Some researchers think it's almost inevitable. If we can, we probably will. That could mean we're not just inside a simulation, but we might create others, stacking simulated worlds inside each other like nested boxes. Think of the possibilities. One day, someone might build a perfect simulation of Earth in the 21st century. The people inside it would live out their lives, never suspecting that they're digital copies. And they might, in turn, build their own simulations, continuing the chain. For now, these ideas are just theories, ways to stretch our understanding of what reality could be. There's no evidence that someone is behind the scenes, typing out the lines of your life. But there's no evidence that there isn't either. As you lie in bed, you can let that question settle in your mind. Maybe the programmer is a far-off civilization, curious about its past. Maybe it's a machine that's been running for eons. Maybe it's something you'll never see or understand. Or maybe it's just an idea. One more way for humans to wonder about where we came from and what it all means. And if someone really is out there running the simulation, maybe they're watching you drift off to sleep, closing your eyes inside the world they built, a world that feels as real as anything could ever feel. If the universe really is a simulation, the obvious question is, why run it at all? What purpose would it serve? It's a fair question, and different thinkers have suggested different answers. From curiosity and science to entertainment and reasons we can't even imagine. Start with one of the simplest ideas. Research. Humans already build models to test how things work. Economists use computer simulations to see what might happen to markets under different conditions. Climate scientists run models to predict how changes in carbon dioxide might affect weather patterns decades from now. Engineers simulate wind flow over an airplane's wing before they build it. These simulations help us make better decisions, plan for the future, and understand systems that are too big or complex to experiment with directly. So it's not a stretch to imagine that an advanced civilization, far ahead of us in technology, might run simulations to answer bigger questions about the past, or even about how intelligent life evolves. One idea is that they might run ancestor simulations. Imagine a society in the far future, long after Earth has changed beyond recognition. The people or beings in that future might wonder what life was like in the past. Instead of digging up fossils and ruins, they could build a detailed digital model, not just of the environment, but of the people themselves, down to their thoughts, emotions, and decisions. In this scenario, every detail of history could be replayed. Researchers could observe ancient wars, see how cultures developed, or study why some civilizations collapsed while others thrived. They could even adjust variables to ask, what if this empire hadn't fallen? Or, what if humans had discovered electricity 1,000 years earlier? It might sound like science fiction, but the basic idea follows a pattern humans already use. We run small-scale versions of this when we build historical models for education or entertainment, from video games that let you play through history to TV shows that recreate the past. A more advanced civilization could simply do the same thing on a much larger, more accurate scale. Another possible reason is entertainment. People already spend countless hours in virtual worlds. Billions play video games, watch movies, or participate in online communities where they create and share experiences. The more realistic these experiences get, the more they feel like tiny simulations. As technology improves, the line between virtual and real gets blurry. It's not hard to imagine a future where a person could live out entire lifetimes in virtual worlds that feel as detailed and unpredictable as real life. In that context, maybe someone built our reality as an elaborate game or story, a kind of immersive experience for someone or something far more advanced. It's a strange idea, but not that different from what people do now. Writers invent characters with complex backstories. Gamers control virtual lives. Directors create movies that feel real for a couple of hours. In each case, the creators don't step in to tell every character what to do. They build the setting and rules, then watch what happens. Another angle is that running a simulation could help answer big philosophical questions. One of the oldest puzzles humans ask is whether intelligent life will destroy itself or survive. A civilization might run countless simulations to see what conditions lead to peace or conflict, growth or collapse. The people inside the simulation wouldn't know they're being studied, but their actions would provide valuable data. Some thinkers even suggest that we might be part of an experiment about consciousness itself. What if the goal is to see how conscious beings experience their world? To find out what love, fear, curiosity, and creativity really mean when they emerge in a system of code and rules. In that sense, every conversation you have, every dream you dream, every moment of joy or sadness could be part of the data. The simulation wouldn't just be about cities and planets, it would be about the minds inside them. Of course, there's another idea. Maybe there's no reason at all. Maybe whoever built the simulation did it simply because they could. Just like a child builds a sandcastle at the beach, not because they need it for research, but because it's possible and interesting to create something and watch it exist for a while. Humans have always made things that serve no practical purpose beyond curiosity. We send probes to distant planets, not because we plan to live there tomorrow, but because we want to know what's out there. We explore oceans, mountains, and caves because we can. The urge to create and discover might be universal. Some scientists and philosophers point out that if a civilization reached a point where they could run realistic simulations, they might run so many that the simulated worlds outnumber the real ones. If that's true, it could mean that running simulations is simply a normal part of becoming advanced, like building telescopes, computers, or spacecraft. The question, why run it, then becomes, why not? If the cost is low enough, and the knowledge or entertainment is valuable enough, there's no reason not to keep creating more. For some, this idea feels unsettling, that life might exist to entertain or inform some outside observer. But there's another side to it. Even if our reality were created for research, play, or curiosity, the experiences inside it would still feel real to us. Pain would still hurt, joy would still lift you up, love would still matter. A digital sunset would still look beautiful to the mind that sees it. It's also possible that if the simulation exists, the beings running it might not interfere. They might not tweak events or micromanage lives. Instead, they could watch the story unfold, seeing what choices people make when they believe they're free. In that sense, the purpose of the simulation might be to let things run naturally, to see what emerges when simple rules combine into something complex and unpredictable. Some people wonder if there could be signs of the simulation's purpose hidden in our world. Could glitches be hints? Are there messages buried in physics? So far, science hasn't found any evidence of a grand secret, but the question keeps people looking and thinking about the limits of what we can know. In the end, no one knows why a simulation, if it exists, might have been started. Maybe it's a research project. Maybe it's a playground. Maybe it's an art form or a way to preserve a moment in time. Or maybe it's something our minds can't even guess. A reason as far beyond us as a computer chip is beyond an ant. As you lie here tonight, you don't need to answer this question. You can just let it sit in the back of your mind. A gentle puzzle that reminds you how much we still don't know about reality. And if we really are living in someone's experiment, that doesn't change how real your pillow feels, how steady your breath is, or how your thoughts drift softly toward sleep. The why may be beyond us, but for now, the wondering is enough. If the idea that the universe could be a simulation raises any hope or fear, it's the question of escape. If everything around you, your memories, your choices, even the stars in the sky, is part of a coded system, is it possible to break out of it? And if you could, would you want to? The notion of escaping a simulation appears often in books and movies. It makes for a good story. A character realizes the world is fake, uncovers the truth, and steps into the real world on the other side. But in reality, it's not so simple. If a simulation is sophisticated enough to be indistinguishable from reality, how would you even spot the edges? Consider how limited your senses are. Your eyes only see a small slice of the light spectrum. Your ears hear a narrow range of vibrations. You can't sense radio waves, gamma rays, or the countless other signals moving through the air right now. To see beyond the limits of human perception, you need tools: microscopes, telescopes, particle colliders. But even with our best instruments, there's always more we can't reach. So, if the simulation has been designed to contain all your senses, thoughts, and tools, the system would cover its tracks well. It wouldn't want its inhabitants to stumble onto a door marked exit. That would defeat the purpose. Some thinkers suggest that even if you did find a glitch or inconsistency, your brain might not be able to process it. If you're part of the simulation, your mind and body follow the same rules as the environment. The escape code, so to speak, might be beyond your capacity to see or understand. There's also the question of what escaping would mean. Imagine you somehow broke free. Where would you go? If you're a mind running on a system, stepping out of the simulation would mean disconnecting from the environment that makes you feel human. Would your consciousness survive? Would you even recognize yourself outside the rules and senses that shape your experience now? In some versions of the simulation idea, the mind isn't separable from the system. The code doesn't just build the world around you, it builds you. Your memories, your thoughts, your personality. All data, all processed by the simulation. Without it, there may be no you to escape. There's a famous philosophical idea called the brain in a vat, which you've heard about before. It shows how deeply our sense of self is tied to our inputs. If your brain sits in a jar and receives signals that make it think it's walking through a forest, then to that brain, the forest feels real. If the signals stop, the forest disappears, and so does the experience of being in it. Escape, in this sense, might be like pulling the plug. You'd stop experiencing this reality, but wouldn't necessarily wake up somewhere else. There's no guarantee there's a real version of you waiting on the outside. The simulation could be all you are. Still, some scientists and philosophers like to think about whether there are ways to find hints, tiny cracks in the program that might show the truth. One idea is that inconsistencies in physical laws could be clues. For example, if the simulation can't handle infinite complexity, there might be limits we can detect, like the pixelation of space at the Planck scale, or cosmic rays arriving with slight distortions. Others have suggested that if we ever develop a quantum computer so powerful it strains the underlying hardware of the universe, it might cause the simulation to glitch or crash. But so far, no experiment has produced such evidence. The universe appears to handle our probing just fine. There are even proposals for cosmic tests. A few physicists have proposed studying the behavior of high-energy cosmic rays. If the universe is a grid, like a giant three-dimensional lattice, we might see unusual alignments in how particles spread. But these studies are complex, and results are inconclusive. So far, the world keeps behaving as it always has, solid, predictable, and stubbornly consistent. The idea of escape sometimes blends with spiritual or philosophical questions. Some people see parallels between the simulation theory and older ideas about enlightenment, the notion that reality is an illusion that can be transcended. In Buddhism, for example, the world of appearances is called Maya, a veil that hides the deeper truth. Meditation, study, or ethical living might free a person from this illusion. But even then, escape isn't a physical door you step through. It's a change in how you see your place in the system. In the modern world, this idea can be comforting or unsettling, depending on how you look at it. If there's no way out, maybe it's better to focus on the life you have inside the simulation. After all, this life feels real. It has meaning because you give it meaning. Pain hurts, laughter feels good, and your connections with other people matter, even if they're all code. On the other hand, some people wonder if it would be worth looking for a way out, just in case. What if there were a glitch so big you couldn't ignore it? What if someone found a way to communicate with whoever or whatever is running the system? Would they listen? Would they care? These questions push us back into science fiction, stories of rebels breaking free, or beings who learn the truth and use it to their advantage. In the real world, the practical ways to escape are more down to earth. You can stretch your mind through learning, meditation, or art. You can test reality by studying science and searching for patterns. Or you can simply accept that the simulation, if it exists, is all you'll ever know. For most people, that's enough. After all, even if the universe is a simulation, it's a vast and fascinating one. There are still mysteries about how stars form, how black holes work, how consciousness arises. There are more questions than any single person could answer in a lifetime. And those questions make life rich, whether you believe you're living in base reality or a highly detailed program. So, can you escape it? No one knows. Maybe there's nothing to escape from. Maybe the idea of a hidden exit is just another way humans test the boundaries of what they can imagine. Or maybe the whole point is that you're meant to stay right here, to explore the world you have, make connections, and find meaning within it. Tonight, you can let that question rest for now. The walls around you are real enough to touch. Your thoughts are yours to keep. And the comfort of your blanket, the sound of your breath, the small details that make up your world, they're here for you, whether you're part of a simulation or not. And if there's no exit, that's fine. This place, this moment, is enough. If you set aside the science fiction stories for a moment, the idea that our universe could be a simulation still holds the interest of real scientists. Not because they think we're definitely living in one, but because it touches questions that physics, cosmology, and computer science already ask. One reason scientists even entertain this idea is because of how well mathematics describes reality. When you drop a ball, its motion follows clear equations. When planets orbit a star, they obey the same laws, no matter where they are. Some people look at this and wonder, why does the universe run so precisely, as if it's following a set of coded instructions? It starts with the fact that physics depends on constants, numbers that don't seem to change. The speed of light in a vacuum, the gravitational constant, the charge of an electron. These values are the same here on Earth as they are in a galaxy millions of light years away. If they were different by even a tiny amount, stars wouldn't form, or matter wouldn't behave the way it does. The fact that they're so precise is one reason the simulation idea feels possible. If you were going to build a virtual universe, you'd set rules that everything must follow. Then there's the strange world of quantum mechanics. Quantum mechanics describes how things work at the tiniest scales, atoms and particles smaller than atoms. Here, particles can act like waves, and particles at the same time. They can exist in multiple states until someone measures them. It sounds like magic, but it's backed by countless experiments. One of the weirdest aspects is quantum entanglement. Imagine two particles that are entangled, linked in such a way that changing one affects the other instantly, even if they're far apart. Albert Einstein called this spooky action at a distance because it seemed to break the rule that nothing can travel faster than light. Yet experiments keep proving it happens. Why does this matter for the simulation idea? Some physicists think that quantum strangeness hints that the universe might be storing and processing information the way a computer does, efficiently, only when needed. In quantum mechanics, a particle's state isn't set until it's observed. It's like a video game that doesn't render parts of the world you can't see to save processing power. Another clue comes from the study of cosmic rays. Cosmic rays are high-energy particles that come from far away in space. They hit Earth's atmosphere at nearly the speed of light. Some scientists have looked at how these particles spread and interact, hoping to find patterns that might show the grain or pixel-like structure of space. In 2012, researchers at the University of Bonn proposed that if the universe were a grid, there might be a limit to the energy of cosmic rays, an edge where they bump up against the resolution of space. So far, no clear evidence has been found, but it's a testable idea. Another area that attracts attention is the holographic principle. This concept comes from black hole physics. In the 1970s, the physicist Stephen Hawking and his colleagues discovered something strange. The amount of information you can pack into a black hole is related not to its volume, but to its surface area. It's like saying what happens inside a room could be described entirely by the data on its walls. Later, this principle was expanded to suggest that our entire universe might work this way. The idea is that the three-dimensional world we see could emerge from information stored on a two-dimensional surface far away, a cosmic boundary. In 1997, physicist Juan Maldacena published work showing that certain kinds of universes could be exactly equivalent to a lower dimensional description on their boundaries. The math works beautifully in special cases, but it's still an open question whether this applies to our own universe. If it did, it would mean the deepest level of reality is not the stars, planets, and empty space we see, but bits of information on a distant surface, not so different from how a computer screen turns data into a picture. Physicists also examine the universe's fine-tuning. This is the observation that many physical constants appear to be just right to allow matter, stars, planets, and life to exist. Some see this as a coincidence or the result of a multiverse, countless universes, each with slightly different rules, and we happen to live in one where the conditions work for us. Others argue that fine-tuning could be a sign that the universe was set up intentionally, like settings in a simulation. But the science here is cautious. Most researchers don't leap to the conclusion that we're living in a simulated world. They see the simulation argument as an interesting thought experiment, a tool for exploring questions about information, consciousness, and the limits of what we can know. One practical reason for this caution is that the idea is hard to test. Science relies on experiments and evidence. For the simulation idea, there's no clear experiment that would prove, beyond doubt, that we're living inside a computer. Some suggestions exist, but they're speculative. Until someone finds an unmistakable signature of the code, the simulation remains a possibility, but not a confirmed fact. Computer scientists also weigh in on the debate. They point out how much computing power would be needed. Simulating an entire universe, with billions of galaxies, each with billions of stars, would require mind-boggling resources. But the counter-argument is that a simulation might not need to store everything at once. Just as a video game only renders what the player sees, the universe might generate details on the fly, when and where they're needed. Then there's the question of consciousness. Could a simulation produce beings who feel alive? We know we can simulate weather or traffic, but minds? Neuroscientists don't fully understand how consciousness works, so it's still an open question whether you could program it. Some researchers argue that if a simulation were detailed enough, consciousness could emerge naturally, the way patterns arise from simple rules. Others think consciousness might require something special, something a machine can't replicate. The debate is ongoing. What's interesting is how the simulation idea ties together different branches of science. It links physics with computer science, quantum mechanics with philosophy, and cosmology with information theory. It shows how questions about what's real can lead to unexpected connections, like the fact that the math for black holes might explain the universe itself, or that the limits of space could reveal a hidden structure, like pixels. For now, there's no sign that we're close to proving or disproving the idea. But exploring it pushes researchers to test the boundaries of what they can measure. If there are subtle glitches, tiny inconsistencies in the cosmic background radiation, odd patterns in quantum experiments, maybe they'll show up one day. Until then, the science reminds us that reality is far stranger than it looks on the surface. Particles that exist in multiple states, entanglement that seems to break the rules of space, and a universe that might store its deepest secrets on a distant boundary. These are not science fiction. They're what experiments keep showing us. You don't need to solve these puzzles tonight. You don't need to decide whether the universe is a simulation or just an incredibly well-organized system. The point is that science keeps looking, asking new questions, and finding new ways to test old ideas. And in the end, the questions themselves are what drive discovery. The next time you look up at the stars, remember that every point of light out there follows laws we can write down with numbers. But behind those numbers might be an even deeper layer of information waiting to be found. For now, that idea is enough to hold in your mind as you rest. The science keeps moving forward, testing what's real, and you're part of that story, whether you're made of atoms, code, or both. After all the questions about whether the universe could be a simulation, one more remains. If it were true, would it really change anything about how you live your life? It's a practical question, because the idea itself is so abstract. You can read about quantum mechanics, entanglement, the holographic principle, and the possibility of cosmic code, but when you get up in the morning, you still have to brush your teeth, make breakfast, go to work, talk to people, feel tired, laugh, get frustrated. These things feel real because they are your reality, no matter what might lie underneath. Philosophers have long debated whether knowing something about the nature of reality should affect how you live. Take the ancient idea that the world might be an illusion. In some Eastern philosophies, the idea of Maya means that what you see and touch is not the ultimate truth. Yet followers don't stop living or abandon daily tasks. Instead, they might treat life with a certain detachment, not clinging too tightly to outcomes. But they still care for their families, do their work, and enjoy the beauty around them. Likewise, the modern simulation idea doesn't come with instructions. It doesn't tell you what to do with your day. It just suggests that the universe may run on a deeper framework than what your senses show you. But your senses are all you have to experience the world. You can't step outside of them, so your life, your choices, your relationships still matter because they're what you feel. Consider how much of daily life is built on trust in things you can't see. You can't watch gravity pulling you to Earth, but you rely on it. You can't see electricity moving through a wire, but you trust that the light switch works. You don't see your memories stored in your brain, yet you depend on them to tell you who you are. If you learned tomorrow that reality was built from information, lines of code instead of atoms, would you stop trusting your senses? Probably not. You'd still need to walk downstairs carefully. You'd still get hungry and need to eat. You'd still need sleep. The mechanics might be different behind the scenes, but the results are the same for you. Think about the practical consequences. If the simulation is perfect, so perfect you can't detect it, then by definition, you can't act on it. There's no door to step through, no control panel to adjust. The laws of physics work the same way whether they're real or simulated. If you touch fire, you'll get burned. If you jump off a roof, you'll still fall. So you live by the same rules either way. Some people wonder if believing in a simulation could make people feel less responsible for their actions. If it's just a program, they might ask, why should it matter what I do? But think about how people act in other systems. Take a video game. Even in a game world, people feel real emotions. They want to win, help others, create things, or protect characters they care about. Inside a game, the rules are fake, but the feelings are real to the player. In the same way, your choices matter to you because they shape your experience. You feel regret when you hurt someone. You feel pride when you accomplish something difficult. You feel joy when you connect with another person. These feelings aren't less real just because they might be built from code instead of neurons. Another way to look at it is to remember that humans already live inside systems they didn't build. You didn't choose the laws of physics. You didn't choose where you were born, the shape of your DNA, or the environment you grew up in. In a sense, life has always been a kind of system you adapt to. The simulation idea just says that the system might be artificial, not natural. But to you, it makes no difference in how you feel about a warm day, a delicious meal, or a good conversation. It's also worth noting that people are good at adapting to strange truths. When scientists first discovered that Earth wasn't the center of the universe, it was shocking. But life went on. When Darwin proposed that humans evolved through natural selection, many people resisted the idea at first. But it didn't stop anyone from living, working, loving, or hoping for the future. Knowledge can change how you see things, but it doesn't erase the value you place on them. One real consequence of thinking about the simulation idea is that it makes people curious. It leads them to ask more questions about how the world works. It ties together physics, computing, philosophy, and even ethics in unusual ways. It makes scientists test boundaries. Could there be glitches? Could we detect the resolution of the universe? Could a powerful quantum computer one day run its own world inside ours? These questions keep research moving forward, whether or not the answers are clear. Some thinkers argue that the simulation idea could inspire caution too. If we believe it's possible, then we might be more thoughtful about how we build our own virtual worlds. Artificial intelligence is already becoming more powerful. In the future, we may create simulations with digital minds that feel conscious. If so, how we treat those digital beings could raise moral questions. Would they feel pain? Would they have rights? These issues sound far off now, but the simulation idea brings them closer to home. In your day-to-day life, though, the practical impact is minimal. The people you care about don't become less important because they might be data. The things you love don't lose their meaning. A sunset is beautiful whether it's made of photons or lines of code. A hug feels comforting whether your atoms are real or simulated. And when you lie in bed, the simple things, the weight of the blanket, the steady sound of your breathing, the memories you replay, are all still yours. They exist in your mind, and that's enough to make them real for you. If you ever find yourself caught up in the what-ifs, you can remember that even the most advanced physics hasn't found a clear way to prove or disprove the idea. It remains a possibility, not a fact. And unless you find a glitch that you can test and repeat, the universe continues as it always has, full of patterns, surprises, and rules you can explore but not break. You might not know the ultimate nature of reality. You might never know. But your experience is still yours. You feel the world. You remember it. You imagine it. That's true whether you're in a base reality or a perfect simulation. So, does it change anything? For most people, probably not. You still wake up in the morning with the same needs, questions, and moments of wonder. You still try to be kind, to understand others, to make sense of what happens. You still feel sadness when you lose someone and joy when you find something that matters. That's the paradox. The simulation idea is huge and mind-bending, but its impact is as small or as big as you let it be. You can get lost in it if you want, or you can shrug and say, maybe, but I still need to get up tomorrow and live my life. In that way, maybe it's freeing. You can't change the rules of the system, but you can decide how you play within them. And whether this world runs on code or atoms, you're here right now, thinking, breathing, wondering, and that's real enough for tonight. Every night, whether you realize it or not, you spend hours living in a reality that isn't quite real. You close your eyes, your brain shifts gears, and dreams appear. Images, places, conversations, and faces that feel as vivid as anything in your waking life. In a dream, you might fly over a city, walk through a house you've never seen before, or have a conversation with someone who's been gone for years. Sometimes you know you're dreaming, sometimes you don't. The moment you wake up, it can all vanish, leaving behind only fragments that fade as the day begins. It's a familiar part of being human, this nightly reminder that your mind can build a whole world from nothing but memories, ideas, and feelings. You don't need a computer or a programmer. Your brain handles the simulation automatically, using billions of neurons firing in patterns that no one fully understands. Scientists still don't know exactly why we dream. Some think it helps us process memories, sorting through the events of the day and storing what matters. Others believe dreams allow the brain to solve problems it couldn't tackle during waking hours. Some think dreaming helps regulate emotions, letting you work through fears and desires in a safe, imaginary space. What's clear is that your brain doesn't need an external machine to generate a world. It can do it all on its own. When you dream, you experience sights, sounds, touch, and even taste. You might feel pain or pleasure, fear or relief, all inside your head. This simple fact connects directly to the idea of a simulated universe. If your brain can create an immersive world every night, how different would it be for a much more advanced system to do the same thing on a larger scale? Maybe the waking world you trust so deeply is another kind of dream, one built from rules so consistent and convincing that you never question them, except in rare moments of doubt. Dreams remind us that perception and reality are deeply connected. When you're asleep, your dream feels real because your brain accepts it as real. If you dream you're running from danger, your heart might race. If you dream you're laughing with a friend, you might wake up smiling. The experience is real to your body and your emotions, even if the setting was imagined. This idea echoes through philosophy too. In the 1600s, René Descartes wondered how he could be sure he wasn't always dreaming. The vividness of dreams made him question whether there was any way to prove that waking life wasn't just another dream. His answer was famously simple. The one thing he couldn't doubt was that he was thinking. I think, therefore I am. Today, neuroscientists study the sleeping brain with brain scans and electrodes. They can measure the electrical patterns of dreams, watch the eyes dart behind closed lids, and see how certain regions light up when a person dreams of running, talking, or seeing familiar faces. Yet for all this technology, no one can look at a brain scan and know exactly what story is playing out. The details live in your mind alone. In this sense, dreaming is like a personal simulation that only you can experience. There's no shared dreamscape, at least not one we can confirm. But some people have tried. Throughout history, there have been stories of shared dreams, visions, or moments when two people claim to see the same thing while asleep. Science hasn't found evidence to support this, but the idea stays with us because it touches a simple question. Can our minds connect in ways we can't see? Some researchers compare dreaming to virtual reality. In VR, a computer tricks your senses into believing you're somewhere else. In a dream, your brain does the same. The realism depends on how well the program runs. The difference is that in VR, someone writes the code. In your brain, the code is the millions of connections built up over a lifetime of memories, experiences, and emotions. There's another layer to this: lucid dreaming. In a lucid dream, you become aware that you're dreaming. Some people can even control the dream, flying at will, changing the setting, or talking to dream characters. It shows that your mind can, in rare moments, wake up inside its own simulation and take the controls. People train themselves to do this by reality checks, asking during the day, "Am I dreaming?" So the habit carries over into sleep. If you can answer yes inside a dream, you gain a level of awareness most dreamers never reach. It's a fascinating parallel to the bigger question about the universe. could we ever become lucid in our waking world and see the code underneath? So far, there's no sign that we can. But the idea lingers that we might someday recognize the edges, the glitches, or the limits of the system we live in. Just as a lucid dreamer realizes the walls are illusions, maybe a conscious being could realize the rules of the universe are instructions, lines of code instead of immutable laws. This thought doesn't mean you have to feel lost or powerless. On the contrary, it shows how creative and flexible your mind is. Every night it writes its own rules, generates its own settings, and lets you live them as if they were real. It means the line between real and imagined isn't as clear as we'd like to think. Dreams also show that meaning comes from within. A dream conversation with someone you love can make you feel close to them, even if they're far away or gone. A dream fear can make you sweat and shake, even though there's no actual threat. The emotions are real because you experience them. It's the same with waking life. Whether the world is atoms or code, it feels real because you live it. You can think of the simulation idea as a reminder that the world might be more like a dream than you expect. Structured, yes, but still built from perception, memory, and the way your mind makes sense of signals. In that sense, maybe you really do dream in code. And if your waking life is another kind of dream, then your actions still matter. You shape your experience by how you treat people, how you solve problems, how you respond to what happens. You might not be able to change the program, but you can change your path through it. At the end of the day, the simulation idea brings you back to the same place, lying in bed, drifting towards sleep, about to enter a world your brain builds just for you. That's a small but powerful reminder that reality isn't only what your eyes see or your hands touch. It's also the story your mind tells you, the patterns it creates, and the choices you make inside them. No one can say for sure what lies outside the simulation, if there even is an outside. But within it, you have the same tools you've always had: curiosity, memory, imagination, and a mind that can build entire worlds while you sleep. So tonight, as you feel yourself drifting off, remember that the same brain that asks, "Is this all real?" will soon spin up a new story. No code needed, no programmer required. Just you, your mind, and the infinite patterns waiting behind your closed eyes. So now, as you settle deeper into sleep, you can let these ideas rest with you. The questions, the doubts, the wonder about what reality might be made of. Maybe we're lines of code. Maybe we're atoms and stars. Maybe we're both. Sleep well and let the questions wait for tomorrow. After all, real or simulated, this is your reality, and tonight, that's enough.